All right, so our vocabulary for today is a scale is a ratio between two sets of measurements. A scale drawing is a proportional two-dimension drawing of an object. All right, so our objective today is we're going to make scale drawings and use them to find actual dimensions. So, our step it out. The scale on a scale drawing can be shown in the same unit or in different units. Mario's school is building a basketball court from the scale drawing. So you can see the drawing is in inches, so 6 inches and 2.1 inches are 2 1/10 inch. And then the actual length is 12 feet and 42 feet. All right, so the first thing that they're asking us to do, the table shows some links from the drawing and the corresponding links on the actual court. How can you tell this is a scale drawing? Well, let's look at the ratios. So if I do y, this is x, remember, and this is y. If I do y divided by x, do I get the same ratio? So if I do 12 divided by 6/10, I get 20. And if I do 42 divided by 2 1/10, I get 20. Okay? So how do we know the ratios are equivalent? So that's how we know that the corresponding links, because they're equivalent. All right, so the next one says, what is the scale of the drawing in inches to feet? So that's how I'm going to set that ratio up. So we know that 1 inch equals 20 feet, because that's what we found up here. We found that scale. So this is K, so K equals. So now that we know what K equals, how do we set up that equation? Y equals 1 over 20x. So that is the equation. Okay? All right, so let's move it up. And it says use the equation in part C to find the actual length represented by a scale drawing length of 1.5 inches. Excuse me. And to find the scale drawing length that represents an actual length of 70 feet. All right, so what we're going to put here is 1.5, or 1 5/10, because that's what it asked us for. The length is 1.5. So if you remember, when we solve an equation, I need x by itself. And to do that, I have to multiply by the reciprocal. So 1.5, I'm going to rewrite it over here. I'm going to move the x over. So in order to get rid of it, we have to multiply by the reciprocal. Because what happens is, this gives me 20 divided by 20, which is 1, and that 1x is just x. So x equals 20 divided by 1.5, times 1.5 is 30. So x is 30. So when we have 1 5/10 inch on the scale, the actual length would be 30 feet. Okay, so now we're going to go backwards because now we know the actual length. The actual length is 70, so that's going to go in for X. And then they kind of skip the step here, so we're going to do 1 over 20 times 70 over 1. So that gives me 70 divided by 20. And 70 divided by 20 goes in there 3 times, which is 60, right? And then that leaves me with 10 over 20. But we should know that 10 over 20 simplifies to 1/2. So if it is 70 feet in real life, it is 3.5 inches on the scale drawing. So questions on that page? No? All right. So let's move on. Still no more.
Excuse me?
Yes.
What's the answer behind the 70?
Oh, this one would be the 3.5.
Okay, thank you.
Yeah, or 3.5, however you want to write it. Okay, so move on. All right, so number 2. What is the relationship between the area in the scale drawing and the area on the basketball court? So A says, show how to find the area of the court in the scale drawing. Well, area, remember, is length times width or base times height. So we would do 4 2/10 times 2 5/10. So 4.2 times 2.5 gives me 10 5/10. And then our units would be inches squared. Okay? So then B says, show how to find the length and width of the actual court. So if we know that this is 4.2 and our scale is 20 feet, so we're going to take that 4.2 and we're going to multiply it by 20. And then we're going to take the 2 5/10 and we're going to multiply by 20 because we need the dimensions in real life. All right, so when we do 4 2/10 times 20, that gives me 84 feet. And then 2 5/10 times 20 gives me 50 feet. So what is the actual area? Well, 84 times 50, not 20, times 50, and that gives me 4,200 feet, and it would be squared because it's area. Okay? All right, so it says, is the ratio of the actual area, okay, so the actual area is 4,200, and the drawing area is 10 5/10, the same ratio as the lengths to the drawing lengths. Okay? So our scale, remember, is 1 to 20. So the actual is 20 over 1. And then this one, so 4,200 divided by 10.5 is 400. So are they the same? No. Okay, but this is a multiple of this, which is 20. It's 20 times as much. But no, they are not the same. Okay? All right, any questions on that one? Okay. All right, so let's move on. So we're going to look at number 3. All right, number 3 says Mario's school is also planning to make a rectangular garden 6 feet wide by 70 feet long. So we know the actual dimensions. So now we're trying to draw the scale. So on the grid provided, make a scale drawing of the rectangular garden using the scale given. Write an equation for the actual length y based on the drawing length x. All right, so we know the scale is 20 feet for 3 units. So the equation would be just that. 20 divided by 3x. Okay? If you want to divide it, you can, but it is not a pretty number. It's a repeating decimal. And so if I rounded it, I get 6.67. But it is not pretty. It's a repeating decimal. Because it's 2/3 of that percent. All right, so use the equation you wrote in part A to find the scale drawing lengths, then make the scale drawing. So I'm going to go back to the fraction. I'm going to use the fraction, not this decimal. Okay? So y equals 20 divided by 3. We know the actual dimension is 60 and 70. So that is what I'm going to multiply by. Actually, I'm sorry, I did it backwards. 60 is the actual, right? So 60 would go here. My bad. Because this is the actual. So the equation, like we did on the top one, is I got to take the reciprocal. I got to get rid of this. So 60 times 3 over 20 equals 3 over 20 times 20 over 3x. So then what happens is this goes away. And so I end up with 180 divided by 20, and 180 divided by 20 is 9. Okay, so that means I'm going to draw 9, or use 9 squares. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 squares. And that should be right because 3 of them should represent 20, right? So 1, 2, 3. So this would be 20. 1, 2, 3. This would be 40. And then 1, 2, 3. That would be 60. So that would be right based on this unit. 3 units is 20 feet. Okay? So then the next one is 70. So 70 equals 20 over 3x. So we're going to multiply by that reciprocal. So 70 times 3 over 20 equals 3 over 20 times 20 over 3x. So that goes away. So 7 times 3 is 210 divided by 3. So 210, not 3, it should be 20. Where did I get 3? Do not know, divided by 20, because it's 20 there. All right, so $210 divided by 20, my lights went off, so that's why it got dark, guys. Let me stand up, move around. Come on. There we go. All right, so 210 divided by 20 is 10 and 1/2. So I'm going to need 10 squares and then half of one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then half of one. So that means it's going to cut, this line is going to cut half. Okay, so that's what your square should look like. Or really, it's not a rectangle, right? Not a square. Because this is 9 and this is 10. Okay? All right, questions on number 3? Okay, do I need to let it sit here so people can copy?
Yes, ma'am.
All right. All right, so moving on. All right, so number 4. Mario's school is also planning a smaller rectangular area as a sitting spot. A scale drawing of the sitting spot is shown. Redraw the sitting spot on the grid at a scale of 1 to 4. Okay, so that means it's going to get smaller, right? Because I went from 1/2 to 1/4. So my square is going to be smaller. So, write and simplify the ratio of the new scale to the original scale. Okay, so the new scale is 1/4. The old one is 1/2. So remember, what does this mean? It means it's 1/4 divided by 1/2. So we've been working with these division of fractions. So remember, what do we do to this division symbol?
We turn it to a multiplication.
Yep, thank you. So 1/4, and then do what to this number? Anybody can answer.
Change the denominator.
Change it. Yep, flip it. Thank you. So 2 times 1 is 2, and 4 times 1 is 4. So this answer reduces to 1/2. Okay, so it says each side of the new drawing will be, well, we already know it's going to be shorter, right? Because we're going from 1/2 to 1/4. All right, so we're going to draw the rectangle. So what that means is I'm going to half this. So this is 1, 2, 3, 4, 5, 6. So now if I'm taking half of this, my new one's only going to be 3 units. So 1, 2, 3, straight across. Okay, how many is here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So half would be 5. So 1, 2, 3, 4, 5 over 3 and down. So 5 and 3, and then this was 6. Okay, so here's the original, here is the new drawing. Okay? Alright, so the turn and talk says, what other ways could we have found the new scale drawing? Well, I could have used an equation, right? So y equals 1/2 x. And so I believe if we would have substituted in 6, we would have had 1/2 times 6 over 1, and that would have given me 3. And then we could have substituted in 10 over 1, and that would have given me 5. So we could have used the equation. That would have been the other way. Okay? All right, so I want you guys to work on the check understanding. Okay? I want you to be able to struggle a little bit with it before I come in and just help you with it. Okay? So I'm going to give you about 10 minutes because class isn't over until 11:14. So about 10 minutes, and then we will go over the answers. Okay? And then as usual, we'll do the on your own next week, I believe. And guys, this is the last section of the book. So that means you will have a module test next week. Right now it's scheduled for Friday, but that's all going to depend on the HMH diagnostic. Okay? All right, so go ahead and work on that check understanding. So the dimension of an Olympic swimming pool is shown. A scale drawing of a swimming pool has dimensions of 50 centimeters and 100 centimeters. And the diagonal that is about 112 centimeters long. So what is the scale of the drawing in centimeters to meters? All right, so anybody have any idea what we're going to do? So it's centimeters to meters.
Divide?
Yeah, we're going to divide, right? So we would take what? What would we divide?
50 to 112.
Okay, close. The 112 is the diagonal, so that's not the dimensions. But you are using 50, okay? But what did it ask for? So we would do 100 by 50. Okay, so then that would give me 2 to 1. So 2 centimeters to 1 meter. Good job, both of you. So it says, what is the actual length of the diagonal of the pool? Right, so we know it's 112, right? Centimeters. And we're going to divide it by 2. So we would get 56 meters for the diagonal of the pool. And actually what we should have done up here, right, we really should have done 100 centimeters to 50 meters, and then it would have been 50 centimeters to 25 meters. That's how we ended up with this, with the 2/1. And it should have been backwards. So I think it was Samir. You actually said it right because it was centimeters to meters, right?
Yeah, it was me.
Yeah. So it actually should have been, I should have flipped this. So it should have been, like you said, 50 divided by 100. Yeah. So this would have been reversed. No, wait. I'm sorry. We were right. 100 centimeters to 50 meters. Yeah, because it's centimeters to meters. So, I'm getting myself confused here. All right. So 2 to 1. So it said, number 2 says, a different scale drawing of the same Olympic pool uses a scale of 5 to 1. What are the dimensions of the drawing? So this is, hold on, I've got to correct this. So 1 centimeters to 50 meters, and 50 centimeters to 25 meters. Okay, so anybody have any idea what we would do here? No? All right, so 50 times 5, so that would be 250 centimeters, and then 25 by 5, because that's my scale, would be 125 centimeters. So that's how we would do that one. Okay? All right, so on everybody got that? Anybody have any questions? That's before I move on.
No.
No? Okay. All right, so on not Monday, because Monday is a holiday, so please don't log in on Monday, okay? That is a holiday. So on Tuesday, we are going to take the HMH diagnostic, okay? When we take that diagnostic on Tuesday, everybody's camera has to be on. If you have camera issues, I need for you to shoot me in the Collaboration Central a little thing that says my camera doesn't work, okay? And then I need to work on what the workaround is, okay? Because when you're taking these diagnostics, I have to make sure that you are taking the diagnostic and not somebody else in your family, okay? So if you do have a camera that does not work, you know how to do it, right? Hit @ and then hit Lavelle, and that way it comes directly to me to know that your camera is not working. Okay? So that is the plan.